Alright, this video is going to be over Objective 4, significant figures, and last year in chemistry you learned about these and you use them throughout the year. I will talk about them in the beginning. All my answers on any key will be in significant figures. However, I'm not going to take points off unless you're being ridiculous with your rounding, so I'll talk about that more in class. So significant figures, or sig figs, are used to report a number to the correct number of digits. So you're not making up data or relying on data that is not true. For example, if I asked you how far away from school you lived, and you said 1.3284567 miles, and I would be like, how did you measure that? Well, I just drove my car and I looked at the odometer, and that's about what it was. And really, that would be lying because your odometer is not that specific. So you can't make up digits that aren't true, and you can't start calculating with digits that are not true. So this only pertains to lab numbers because they have limited number of digits that it can report out to. So that's why you don't use them in math class. So looking at this, these rules are rules to follow for sig figs. And for the first chapter, you have to do sig figs, but like I said, throughout the year, I'm not going to mark you down, only if you're very off with your reporting. So anyway, every non-zero number is significant. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you see one of those, it's significant. Zeros between non-zero numbers are significant. So if you look at this number, 1,002,103, those zeros count because they're in between two significant figures, 1 and 2. That zero also counts because it's between 1 and 3, two significant figures. Rule number 3 says zeros in front of non-zero numbers are not significant. Don't count placeholders. So all these zeros in front don't count. This one counts because it's in between, and those two are also in between, so they count. So this would only have 1, 2, 3, 4, 5, 6 sig figs. The fourth rule, zeros behind a non-zero number to the right of the decimal place are significant. So remember, these numbers in front don't count, but since there's a non-zero, these zeros behind start counting. So zeros to the right of the decimal are significant after a non-zero number. So we got the 1 is a non-zero, so then they start counting. So this would have 3 sig figs. Number 5, zeros after a non-zero number with no decimal point are not significant. So if you have, this zero counts because it's between two non-zeros, so far we have 3. Those don't count because there's no decimal point there at the end. That means those were all estimated. So this would only have 3 sig figs. So if you want those zeros to count, let's say your instrument measured that precisely, you know it's exactly 0 at the end, then you need to add a decimal point. So 100 itself only has 1 sig fig. With a decimal point added, it has 3 sig figs. That means it's exactly 100. This could be 120, 130, it could be 98. This means it's exactly 100. So, and that would have 3 sig figs. So what if you wanted to show 10,000 with 2 sig figs? Well, that's hard to do because there's nothing you could put there. It's only got 1 sig fig when it's written like that. But you know it's exactly 10,000, so how would you show that? Well, you need to use scientific notation to do that. So if you change this number to a number between 1 and 0, you can put your or 1 and 10, excuse me, to write it in scientific notation, you would put it right here. So it's 1.0. The reason it's 1.0 is because you need 2 sig figs, and that has 2 sig figs. So you write 1.0. Well, how do you make 1.0 into 10,000? Well, ask yourself how you move it back to where it came from. You'd have to go 4 places to the right, so it's 10 to the positive 4th. And that would make your 10,000, and then you have 2 sig figs. So when you have a scientific notation number, kind of cover up the second half of the number, so cover up this piece, and look at the front. I'm going to look right up here. And look at how many sig figs that has. 1.0 has 2 sig figs, so that works. So let's do a little review on sig figs. So looking at A, the 0 between counts, this one's also in between, and it's also after a non-zero to the right of the decimal place, so that counts no matter what. So we have 5 sig figs, all of them count. This 0 in front does not count. The 8 and the 3 count, of course. This 0 in between counts. This last 0 also counts because it's after a non-zero to the right of the decimal place. So that has 4. These zeros in front here do not count. This 0 is in between, so it counts. So we have 6, 0, and 3 all count, so you have 3 sig figs. 450, since there's no decimal point there, only the 4 and the 5 count. There needs to be a decimal point, just like we talked about up here. So that one only has 2. Looking at E, the 3 definitely counts, and we have a decimal point there, so that means we know it's exactly 300. So all of those would be significant because of that decimal point, so it has 3. Looking at the next one, F, we have 20.00. Well, this decimal point's there, so that definitely counts, that 0 counts. These are after a non-zero, even though it's way up here, they're after a non-zero to the right of the decimal place, so it's exactly 20.00. So it has 4 sig figs. Looking at G, those zeros in front don't count, so you only have 1, and that's the 7. And looking at H, you got 350.0, so you got the 3 and the 5 count. Because that decimal point's there, this 0 counts. This 0 is after a non-zero to the right of the decimal place, so that counts also. So exactly 350.0. So all 4 of those count, which is 4. 1.004, those zeros are in the middle, so they count. So it has 4. Looking at this one, these zeros in front do not count. This 0 counts because it's in between. These last 2 zeros count because they're after a non-zero to the right of the decimal place. So we have 1 on the 2 counts. So there's 1, 2, 3. Sorry about that. So looking at the decimal, or how many sig figs there are, they all count. So it's 1, 2, 3, 4, 5, 6. So there's 6 sig figs. So it's also important to calculate using sig figs. So we have addition and subtraction, and this is how do you add and subtract using correct number of sig figs. And like I said, for this chapter we'll focus on this, and then after this it's good to know these rules and follow them because my answer keys will be that way. However, I'm not going to mark you down for it. So we're going to line up the decimal points and round off the final answer to the least number of decimal places. So when you add and subtract, you don't even use the idea of significant figures. All those rules we just learned, you don't even use it. You just use the least number of decimal places. So we have these 3 numbers. You look at how many decimal places there are. This one has 4, this one has 2 decimal places, this one has 1. So when you add them up like usual. You have your answer, 30.871. You should only have 1 decimal place according to the sig fig rules. So 1 decimal place gives you the 8 there. So if you look behind the 8, it's a 7. So what do you do to the 8? Would you round it up or keep it the same? Well, you have to round it up because it's a 7, just your regular rounding rules. So now it's 30.9 meters. And you can see you have the 1 decimal place. That's the least amount in all your numbers from the beginning. Looking at the next example, we have 2 decimal places and none. So that means in your answer you can only have none. So you subtract them like usual. You get 42.38, and you shouldn't have any decimal places. So you look behind the 2, it's a 3. So would you round it up or keep it the same? Well, you would keep it the same because it's a 3, so that rounds to 42 liters. The last thing in this objective for sig figs is how to multiply and divide using correct number of sig figs. What you have to do is figure out the number of sig figs in each of your original numbers that's there, and round the final answer to the least number of sig figs. So for multiplying and dividing, you actually follow your sig fig rules. So if you look at this, you got 3.20, it has 3 sig figs, and then you have 22,100. That one has 1, 2, 3. Those zeros don't count because there's no decimal point, so that has 3 sig figs. So you have 3 sig figs and 3 sig figs here. That means in your answer you can only have 3. What's less between 3 and 3? Well, they're the same, so you can only have 3. So looking at your answer, and it looks like I rounded something wrong here, so sorry about that. I'll take a look at it. We got, yeah, definitely did it wrong here. So you get 3.20 times 22,100, you get 70,720 meters squared. Well, looking at that then, you should only have 3 sig figs, so the 7 counts. The 0 counts because it's in between, and so does the 7. You always start at the beginning of the number. So after that second 7, you have a 2. Would you round the 7 up or keep it the same? We'd keep it the same. So then it becomes 70,700, and that would have the 3 sig figs. So make sure you change that. That's another mistake. So 70,700. 700 is what you should have as your final answer with 3 sig figs. Okay, look at the second example. This has 4 sig figs because that 0 between counts. This one only has 2 because those zeros in front don't count, and that 0 is after a non-zero to the right of the decimal place. So this one has 2 sig figs. So 4 and 2. So when you divide, you get 51.05 grams divided by liters, so grams per liter. Then you have to have only 2 sig figs in your answer because you have to take the less amount. So you should only have 2. And when you do that, you start at the beginning. This 5 counts and the 1 counts, of course. So you have the 2 that you need. So you look after that, it's a 0. So you keep it the same. So this would round to 51 grams per milliliter with only 2 sig figs. And that concludes objective 4.